Welcome again. I am Obi. Hello, welcome to take you on the subject chemistry. The theme of this lesson is chemistry and industry. I'll be taking a topic, metals and their compounds, part 2. And by the end of the lesson, you should be able to list the properties of alkali metals, describe the extraction of sodium, list some of the uses of sodium, and list some compounds of sodium. So looking at sodium very much in this lesson. Now the alkali metals are the group 1 elements, okay? And they are lithium, sodium, potassium, rubidium. Here we have a diagram showing us the alkali metals with the exception of hydrogen. Of course, hydrogen is a non-metal, is not alkali metal. So we have lithium, sodium, potassium, rubidium, cesium, and francium. They derive their name from the fact that they react with water to form alkali. So that is why they are called alkali metals. For example, sodium reacts with water to form sodium hydroxide, okay, which is the alkali. So that's why they are called alkali metals. Alkali metals react with water to form their hydroxides and hydrogen gas. So for example, lithium, okay, and water, this will react to give us lithium hydroxide plus the hydrogen gas, okay? So we'll have this. So this is the hydroxide. Sodium, potassium, rubidium, francium, all the alkali metals can easily react with water to give their hydroxides. Their reactivity and atomic size increase down the group on the periodic table. So as you go down the group on this periodic table, okay, from lithium to sodium to potassium, their size, the atomic size will increase. Of course, as we are having more electrons being introduced into each atom, the size of the electron is increasing. So the atomic size is increasing as you go down the group. For example, lithium just has 3 electrons. Potassium has 19 electrons, so definitely it's going to be bigger than lithium. And francium has 87 electrons, so it's going to be way bigger than the rest, okay? So the atomic size increases down the group, and their reactivity as well increases down the group, because of course the further away an electron, the valence electron is from the nucleus of an atom, the easier it is for that electron to be pulled away from that atom. So their reactivity increases down the group. So it means that francium will be more reactive than cesium. Cesium will be more reactive than potassium. Potassium will be more reactive than lithium. Alkali metals have 1 valence electrons in their outermost shell. Of course, all the alkali metals, the group 1, that is actually what fetches them that name, group 1 element, okay? They have just 1 electron in their outermost shell. All of them. Therefore, they have a +1 charge, okay? So when they get ionized, they release that 1 electron to become what? Positively charged. And that charge is what? A +1 charge, all right? They are malleable and ductile, just as other alkali metals are malleable and ductile. Now, we'll be looking at sodium as one of the alkali metals. We're taking a case study of sodium. So sodium is a member of the alkali metals, as we have seen, and it is the 6th most abundant element in the Earth's crust. All right? It is a highly reactive metal, and as such, it does not occur freely in nature. In part 1 of this lesson, we talked about very reactive metals, moderately reactive metals, and least reactive metals. We know that from that lesson, sodium is one of the very reactive metals. And we also said that such metals do not occur freely in nature because they are highly reactive, okay? So they react with elements in the environment, elements, compounds, even impurities. They react with all these other elements to give us what we call the metal ore. So you cannot find sodium as sodium in the Earth crust because it is highly reactive. So it does not occur freely in nature, but is mostly found combined with other elements. In seawater, okay, sodium is present in dissolved form such as sodium chloride, sodium bromide, and sodium iodide. It also occurs in deposits as sodium chloride, which is also rock salt, okay? Sodium trioxynitrate 5 and sodium trioxycarbonate 4. It is also found in dissolved form in the human body. Some of the elements that we talk about are found in the human body, and sodium is one of such elements. Now, we'll be looking at properties of sodium. Sodium as a metal. What are some of its properties? Now, sodium has, of course, sodium on the periodic table is found here, okay? It has an atomic number of 11, okay? An atomic mass of 22.98977, all right? So, pure sodium is silvery white and soft. Sodium is a soft metal. It has a very low density of 0.98 and it floats on water because of its very low density. Sodium easily floats on water. It has a melting point of 97 degrees Celsius and a boiling point of 883 degrees Celsius. Sodium is a good conductor of heat and electricity. Now, some chemical properties of sodium. It reacts violently with cold water, okay, to produce the sodium hydroxide and hydrogen gas. Of course, we mentioned this as one of the general properties of alkali metals, that they react with what? Water to produce the hydroxide and hydrogen gas. So sodium is not an exception. So when sodium reacts with water, we are going to be getting this alkali known as sodium hydroxide, and hydrogen gas will be released. Sodium is readily oxidized by atmospheric oxygen to give sodium hydroxide. So when sodium reacts with oxygen, it gets oxidized to what? Sodium oxide. Sodium reacts with the halogens, okay? The group 7 elements such as chlorine, okay? It reacts with such elements to form ionic compounds. Example, we have sodium and chlorine. So when sodium reacts with chlorine, chlorine is a halogen element, okay? It's one of the halogens. It will have what? Sodium chloride. Now we'll be looking at how sodium is extracted. As we have said, sodium is a very reactive metal, and it is extracted industrially by the electrolytic reduction using the down cell, okay? Now this down cell is made up of what? A rectangular container of steel with its inside lined with fire bricks. So here we have an image of a down cell. This is what it looks like, okay? So its inside is lined with what? Fire bricks, all right? And the electrodes in the down cell are separated from each other by a cylindrical steel gauze diaphragm, okay? So the positive anode is a graphite rod that projects upward from the center through the base of the cell. So here we have the graphite rod, okay? And this is the anode of this electrolytic cell, all right? So this anode is a graphite rod that projects upward from the center of the cell. Now the negative electrode, which is the cathode, okay, is a ring of ions surrounding the anode. So we have here the cathode and we have here the anode. Now this is done so that it will be easy for the products, sodium and chlorine, because at the end of this electrolytic process, sodium and chlorine will be produced. So this separation of the electrodes is done so that by the end of this process, the sodium and chlorine produced can be easily kept apart and collected separately. So during electrolysis, okay, remember we talked about electrolysis in the part 1 of this lesson. So we have a basic understanding of how electrolysis works. So during electrolysis, an electric current is passed through the molten mixture of sodium chloride and calcium chloride. Okay, so we have the molten sodium chloride being added with some other chemical compounds. We have it being added into the electrolytic cell. Now, the sodium ion is going to be produced, okay? Remember what happens in the electrolyte. We said that electrolyte is a fluid that contains mobile ions that make it possible for ions to be discharged in an electrolytic cell. All right? So this sodium chloride is going to be what? Dissociated. All right? And the sodium ion is going to be produced in the electrolytic cell. Now, this sodium ion produced in this decomposition of sodium chloride will migrate towards the cathode. Remember that the cathode is the negative electrode. Now, this sodium ion produced is positive. So, it is going to migrate towards the negative electrode, which is the cathode. All right? So, when it migrates to the cathode, okay, it will be reduced to the sodium atom. Remember that when it goes to the cathode, it is going to gain electrons. And that process is called what? Reduction. So when it gains that electron, it is going to what? Be reduced to the atom. While the chlorine ion produced is going to migrate towards the anode, which is the positive electrode. All right? The chlorine ion is negative, so it is going to migrate towards the positive electrode. All right? So it migrates towards the graphite anode, okay? And there it will be oxidized to the chlorine gas. So the sodium ion is reduced to sodium atom, while the chlorine ion is oxidized to the chlorine atom. So the sodium atom given off at the cathode is going to go out through this receiver for sodium. And that is how sodium is produced in this electrolytic process. So here we have the chemistry of the reaction. Sodium chloride decomposes to sodium ion and chlorine ion. At the cathode end, sodium ion is reduced to the sodium atom. So this is what happens. Sodium ion receives electrons, okay, to become the sodium atom. And at the anode end, the chlorine ion gives off electron to become the chlorine atom. So the molten sodium, okay, the sodium atom, the sodium that is now the metallic sodium, is a molten form. So we call it the molten sodium. It collects at the cathode component, okay, where it rises to the top and is removed with a pipe. So the sodium that forms at this cathode rises to the top and it is removed with an iron pipe into this receiver. Chlorine is collected at the anode. Okay, so the chlorine is given off at the anode. Therefore, the overall reaction for the extraction of sodium is given thus: sodium ion being reduced to sodium atom, and chlorine ion being oxidized to chlorine atom. And here we have the overall reaction giving us 2 atoms of sodium and 2 atoms of chlorine. We'll be looking at some compounds that the sodium atom forms, or the sodium metal forms. Sodium produces a lot of useful compounds because of its high reactivity with other elements. Sodium, as we have said in this lesson, is a very reactive element, okay? And because of that, it forms a variety of compounds with other elements. Some important compounds of sodium are sodium oxide, sodium hydroxide, sodium chloride, sodium tetrasulfate 6, sodium bicarbonate or baking soda, sodium thiazocarbonate, and sodium peroxide. There are a lot of compounds that sodium can form, but for this lesson, we'll be looking at these compounds. So let us see how each of these compounds is formed with sodium. Sodium oxide. Sodium oxide can be prepared by gently heating sodium peroxide with excess sodium. Okay? Another way it can be formed is by burning sodium in insufficient air. Okay? So here we have sodium peroxide and we have sodium. When both of them react, we would have sodium oxide. So this is how sodium oxide is formed. Now the next compound of sodium is sodium hydroxide, which of course has this. This is the compound, sodium hydroxide. Now this sodium compound is prepared by heating excess slaked lime with 10% sodium trioxocarbonate for solution. So here we have sodium trioxocarbonate 4 and slaked lime, okay, which is actually calcium hydroxide. So when this reaction takes place, sodium hydroxide is formed, limestone is also formed, calcium carbonate, okay. So the sodium hydroxide formed is concentrated by evaporation. You can actually get more of this or concentrate it by evaporating it to remove its water. Sodium chloride. Sodium chloride occurs naturally, okay, as sea salt. Because we know that sodium chloride is our normal table salt. Okay, so it occurs naturally as sea salt. All right. In some areas, it occurs as rock salt, which is mined as a solid or pumped out as brine from the ground. Sodium chloride can be gotten by allowing seawater to evaporate in the sun. So seawater contains a high concentration of sodium chloride. And for you to get sodium chloride from that seawater, all you need to do is to allow it to evaporate in hot sun. And there you have your sodium chloride. But industrially, sodium chloride can be prepared by neutralizing sodium hydroxide with dilute hydrochloric acid. So when this alkali, sodium hydroxide, is treated with hydrochloric acid, dilute hydrochloric acid, sodium chloride will be formed and water will be given off as a byproduct. Another compound of sodium is sodium peroxide. Okay? Sodium peroxide has this formula. It is prepared by heating sodium in excess oxygen. Okay? So sodium, when heat in excess oxygen, will give us sodium peroxide. Now, this sodium peroxide is stored in airtight containers to stop it from being decomposed into the various elements that make it up. Now, sodium tetroxysulfate is another compound of sodium, and it has this formula Na2SO4. And this compound can be industrially prepared by heating a mixture of sodium chloride and concentrated tetraoxosulfate 6 acid at a high temperature. So when sodium chloride, here we have sodium chloride and tetraoxosulfate 6 acid, okay, this intermediate is formed, and this can also react with sodium chloride to give us sodium tetraoxosulfate 6 acid. Now, this is how we can prepare this sodium compound in the industry, okay? But in the lab, in the laboratory, it can be prepared by the neutralization of dilute tetraoxosulfate 6 acid with sodium hydroxide. So if we have sodium hydroxide and sulfuric acid, sodium tetraoxosulfate 6 acid can be formed with water being given as a byproduct. Next compound of sodium is the sodium trioxocarbonate 5 with this formula. Okay, now this sodium compound exists mainly in the anhydrous form. This anhydrous form simply means in the dry or powdery form. Okay, and this dry form that it exists is called soda ash. All right, but when this soda ash is boiled, okay, in water and allowed to cool, it crystallizes out as what? Washing soda. And this washing soda has what? 10 molecules of water. So, washing soda has this formula. Okay? So, this is sodium trioxocarbonate 5 as what? A decahydrate. So, we have sodium carbonate decahydrate. Now, this hydrated form can be converted back to the anhydrous state simply by heating it to lose all its water of crystallization. So when it is heated, this water evaporates and we have the soda ash that we had before, the dry form. All right? Now, but if washing soda loses only 9 molecules of this water, okay, leaving behind just 1 molecule of water, if that happens, then it gives the second form of this compound, which is sodium trioxocarbonate 4 monohydrate. Okay? Monohydrate simply means that it contains just 1 molecule of water. Now, how do we prepare sodium triisocarbonate 5? It can be prepared in the laboratory by passing excess carbon 4 oxide through a solution of sodium hydroxide. Okay? Now, when this happens, a white precipitate, which is sodium hydrogen triisocarbonate 4, is formed. Now, this sodium hydrogen triisocarbonate formed is insoluble. Okay? Therefore, it is filtered off. When it is filtered off, it is washed with what? Cold water and heated again to remove the water of crystallization. All right? So when sodium hydrogen triisocarbonate 4 is formed, it is filtered off. Now, when it is filtered, it is also now washed with cold water. Okay? After washing with cold water, it is heated again so that the water molecules can evaporate. And when that happens, the anhydrous form is gotten, the soda ash. All right? So this compound can actually exist in 3 forms. The first one is the anhydrous form, which is the dry or powdery form, which we call soda ash. The second form is the hydrated form that contains 10 molecules of water, which we call washing soda, okay, the decahydrate. And the another form is the one in which it contains just 1 molecule of water, which we call sodium triisocarbonate 4 monohydrate. Now, when soda ash is dissolved in hot water and allowed to cool, the crystalline form is obtained. That's the soda ash that is formed. All right? When it is dissolved in hot water again and allowed to cool, it crystallizes as what? The decahydrate. So we have sodium carbonate and 10 molecules of water to give us this one compound known as what? Sodium carbonate decahydrate. Another compound of sodium is sodium hydrogen triisocarbonate 4 with this formula. Okay, now this compound is also known as sodium bicarbonate or baking soda. For those of us that bake, okay, we know the use of baking soda in baking. So this is the chemical compound, baking soda. And this baking soda is prepared industrially by the Solvay process. It is prepared by using carbon dioxide to saturate a wet paste of sodium carbonate. So we have sodium carbonate here plus water and carbon 4 oxide to give us sodium hydrogen triisocarbonate. Now, this sodium hydrogen triisocarbonate is a white crystalline solid that is slightly soluble in water. The next compound we have is sodium triisonitrate 5, and it has this formula, sodium triisonitrate 5. It is also known as Chile saltpeter, and it occurs naturally in combined form called caliche. Now, this caliche is what? A mineral deposit of gravel, sand, and nitrates. All right? Now, to extract this sodium triisonitrate 5 from caliche, the caliche deposits are dissolved in hot water. The solution formed, that is the water and the caliche deposits, okay, is evaporated to recover the triisonitrate 5. So this is one way that we can recover or get sodium triisonitrate 5 from caliche deposits. All right? Now, besides that method of extraction, sodium triisonitrate 5 can be prepared in the lab by the action of sodium hydroxide on dilute triisonitrate 5 acid. So when sodium hydroxide reacts with dilute triisonitrate 5 acid, we will be having sodium nitrate, sodium triisonitrate 5, with water giving off. Now, I'll be looking at some of the uses of sodium. Okay? Sodium forms very important compounds. All right? These compounds, as we have seen when we talked about the compounds of sodium, are very, very important compounds. They are used on a daily basis. All right? Just as we saw baking soda, we know what baking soda is used for, especially for people that bake. So we'll be looking at some compounds of sodium. all right, and what they are used for. Now, table salt, which is sodium chloride, of course, is a sodium compound gotten by the reaction of sodium and chlorine. This compound is used for cooking and for food preservation. Of course, we know the importance of salt in our food. Without salt, our food will be tasteless. Some people also use salt to preserve food, okay, because it helps to stop the activities of microorganisms such as bacteria, okay, and you know that it's those bacteria that cause the decay of food substances. So some people use salt to preserve food. So that's one importance of sodium chloride. Next we have here is baking soda, which is a sodium hydrogen tricarbonate 5. Baking soda is also used for cooking, for example, when we bake, okay? It is also used for cleaning, okay? There are a lot of cleaning importance of baking soda. Some people mix it with other substances to do domestic cleaning around the house, especially on sinks and on tiles, okay? It is also useful for cleaning the teeth. Yes, baking soda can be used with your toothpaste or even just as it is to clean the teeth, to make it white. Another compound of sodium is soda ash. Now, this soda ash is also used in household cleaning products and for dyeing. Some household cleaning products, when you look at the ingredients used in making those products, you see that soda ash is one of the ingredients. Okay? So, it is used in making some of those are household cleaning products that we buy in the market. It's also used for dyeing, for people that are engaged in dyeing activities. Caustic soda, which is sodium hydroxide, is used in industries for the making of soap, plastic wraps, and paper. Okay? Sodium hydroxide serves as an important alkali in soap making. Okay? So, most times, industries that make soap cannot really do without sodium hydroxide. Chile saltpeter, which is sodium nitrate, is used as what? Fertilizer, and in the manufacture of explosives, nitric acid, and glasses. Then we have sodium peroxide. Sodium peroxide is used in the production of dyes. So here we have salt, okay? Here we have sodium baking soda, which is sodium hydrogen tricarbonate. Here we have sodium peroxide, okay? We also have soda ash here. We have caustic soda, and we have the Chile saltpeter. Sodium is an important component in the human body. The presence of sodium helps the brain and nervous system to function well. Sodium amalgam, which is sodium and mercury together, sodium amalgam in water are useful reducing agents. So sodium amalgam in water is used as a reducing agent. Sodium also serves as a reducing agent in the extraction of titanium from titanium tetrachloride. Then we have what we call sodium vapor lamps. These lamps are used as street lights and highway lamps as they give a brilliant orange-yellow light. So here we have an image showing us how a sodium vapor lamp looks like. So here we have the uses of sodium. And with that, we came to the end of this lesson. Let's take a quick summary. We say that alkali metals are the group 1 elements, and they include lithium, sodium, potassium, rubidium, etc. We also say that sodium is a member of these alkali metals, and it is the 6th most abundant element in the Earth crust. Now, we listed some properties of sodium. Sodium has an atomic number of 11 and an atomic mass of 22.98977. Sodium is silvery white in color. It has a melting point of 97 degrees Celsius and a boiling point of 883 degrees Celsius. It is a good conductor of heat and electricity. Sodium is extracted using the down cell, and the overall reaction is given thus: sodium ion being reduced to sodium metal or sodium atom, and the chlorine ion being oxidized to chlorine atom. Some of the compounds of sodium we mentioned are sodium oxide, sodium hydroxide, sodium chloride, sodium tetraoxysulfate 6. Some uses of sodium include: it is used as a reducing agent in the extraction of titanium from titanium chloride and in the manufacture of sodium vapor lamps. Let us take a quick test. Now, sodium is a very reactive metal that is extracted industrially by dash method. A. Thermal reduction method. B. Chemical reduction method. C. Electrolytic reduction method. The correct answer to this question is electrolytic reduction. Remember we said because sodium is very reactive, okay, the only method that can be used to extract it is the electrolytic method. With this, we have come to the end of this lesson. Thank you for staying with me.